Okay, this is lecture for January 21st, and I'm just going to type this as I go along. So I'm not able to get to you to you guys today because of snow. So what I wanted to do is take this opportunity to actually give you an introduction to R. So that's really what this lecture is going to be about. R is a pretty cool statistical software package because, well, A, it works, and B, it's free. So a lot of the more commonly used statistical software packages like SPSS and SAS are being replaced with R because of those two features. You know, if you took 2500 with me, we tried to get to the lab, but the time that we met last fall, there was a class that kind of hogged the lab. So, you know, I thought this is probably a pretty good opportunity to just give you an introduction. So, the things I'm going to try to point out to you today, first of all, how do we download R? I'm going to go through the steps. I've already downloaded it on my computer, but I'll go ahead and give you an illustration of things I want you to be able to do. And by the way, this is not just to waste your time. We're actually going to use R throughout the term, and there will be assignments on R. So, just trying to get you started. Make sure I've got my. That'd be crazy if my audio wasn't up. Next thing I want to teach you how to do. What I teach you to do is to convert an Excel file to what I call CSV. It turns out that I found it easiest if we can do if we can use what's called a comma separated value format when we take our data set and upload it to R. So I'm going to give you a thorough presentation of that. Once we get our file up into R, you know, it's things that I want you to be able to do. So let's just call these basic numerical summaries. I'm going to teach you how to do that, or at least give you an illustration of it. So mean, median, standard deviation, so on. And I want to show you also how to do histograms and box plots. All right. And the final thing, since the topics that we're studying right now are t-test, I want to give you an illustration of how we do unpooled and pooled t-test on R. So, guys, that's what's going to happen. Hopefully, the lecture will last about 30 minutes. I'll upload it to YouTube, as you'll know by the time you watch this. So here goes. The very first thing I'd want you to do. Someone misunderstood me when I was talking about R once, and they were like, "Well, how do you spell that?" Well, literally R. So if we type in R in some search engine, the very first thing you'll see is the R project for statistical computing. If you open that up, located right here, how to download R. So we want to click that. Now the next thing we get into are what are called cran mirrors. This is just an archive network. It's just each one presents its own language, has its own data sets. The one that I'm going to use is the one by UCLA. I've actually tried out most of these under the USA. Iowa State and UCLA are the ones that I like the best, so UCLA is the one I like the best. From here, you know, I have a Mac, so this is what I would choose. And obviously, if you have Windows, you would choose that. And just go through and, you know, obviously download the latest version of the available package. Once you do that, and we'll close this down, what I would do is put R in my dock because, you know, I want it to be easily accessible. All right, once you download it, once you open it, you're going to see something like this. And again, one of the first things I want to do is show you how to to get a data set, in most cases from my stat lab, into R. So what I've done here is, if you go to under document sharing in R, you can see this is under our 3500 statistics 2 for the semester. I've downloaded an XLS file called IQ Read. Now the first thing I would want to do is open this up and save it someplace, and I usually save things to the desktop. So if I go back to my desktop, in addition to showing seeing me throw a football to my daughters, you can see that I have a file here called IQ Read. Now the first thing I want to do is I want to open this up. And make it a little bit bigger for you. And you can see it's got, the reason I want to choose this is it has, I think, 4 quantitative variables, and then gender and school district are actually categorical data. And I coded one as letters and one as numbers for a reason. But the first thing I'd want to do is go in and do a file, and then I'd want to do a save as. Now I'm going to redo this as IQ READ. I don't want any spaces in there for reasons I'll talk about in just a second. I'm going to save this to my desktop, but the format that I want to use, I want to come down to where it says Windows, comma, separated. So that stands for comma separated values. Okay. So I click that, double check everything, save it, and go ahead and continue. Now, next thing I'm going to do is I'm going to shut this down. I'm going to close Excel. I've got things saved like I want them. So you can see now on my desktop, I not only have the IQ Read in XLS format, I have IQ Read in CSV. There is a way that we can upload directly XLS format, but yeah, I've been playing around with R for about the last year, and I've found that the CSV is a lot smoother transition. So it seems like they were able to upload our files in CSV format much better, or much more seamlessly, I would say. Now the first thing we got to do is we've got to get the data from the CSV into R. So the first thing I would do is do what's called get the working directory. In other words, when we access R and tell it to get a data set, where is it naturally going to check? And the way I've got mine, well, this is kind of the default, I didn't set it this way, it's just going to go to ddarbro, which is primarily the name of the computer. Well, I want to change that. And I want to set my working directory as you may expect, to my desktop. So type that in. Now I can go back and get working directory, and I see that my desktop is set as my working directory. So now when I want to go get files, this is where it's going to search, is on the desktop. Now the next thing I want to do is I want to name my data, and I'm just going to name this data. You don't have to use all caps. Just keep in mind that R is case sensitive. So if I use this all lowercase data, then that's the way I would have to access it. Next thing I'm going to do is I'm going to use the read CSV format. And I forgot, what did I name this? IQ Read, yeah. So I want to go IQ Read.csv. So it's going to read the file, and it's going to, using this command right here, it's going to store it as data. So I do that, no error, go data, and you can see that it's input, or it's imported the CSV form, the CSV file into R as data. Now the first command is that we usually look at is the mean, And these are our variables: read, LSS, IQ. These are the variables. Okay, so first thing you typically do is do the mean, and you type in the variable that you want to find the mean of. Well, this is going to give me an error. And the reason it's going to give me an error is the object read is not found. Guys, when you download a data set from your computer into R, for it to be able to read the file, we first have to attach it. Now, since I called this file back here data, I have to attach data before I can use it. So attach data, no error. Now I can come in and I can find the mean of read. So again, you got to call it something, and I usually call it data, and you have to attach it before you can actually find numerical summaries or histograms, whatever it may be. Now, anytime I want to communicate to you, I can put a number sign in front. And that means that I can type things, but R isn't going to see it as a command. So what I'd now like to do is find the mean, median, standard deviation, quartiles, and ultimately histogram and box plots. All right, so found the mean, find the median. I'll tell you what, the easiest way to find the median is to do what's called summary. Not only does it find the median, it finds extra stuff too. So if we do the summary, we can see that we end up getting the 5-number summary, the minimum value, first quartile, the median, third quartile, and the max. But it also gives us the mean. Really, the only two things we'd really need from there would be the standard deviation. If we want the variance, and if we want the IQR, we can type this. So the commands, just as you would expect. Now, again, case sensitive. If I do SD and decide, well, that's not important, well, R thinks it's important. So again, if we capitalize everything, we have to type our data in exactly like that. Okay. Next thing that's kind of cool is the skewness factor. Now, up until now, when we determined skewness, we did it kind of the little boy, little girl way. We looked at the histogram, and that's perfectly fine. But okay. Well, this is interesting. Okay, apparently it's not in the... Okay, I have no idea. It has a skewness factor, and for some reason it's not working on this. I just updated this version, so guys, I'll get back with you on the skewness, okay? And but apparently something has changed. One more thing to keep in mind, if we want the sample size, typically you're in your data set, you can see up here that there are 30 entries, but that isn't always given. So although you would think that you would just type in, what you need to do here to get the sample size, and I want to store this as in, is do length. I'm sorry, let's do length of data. And then if we do in, we're going to see that we have 6 variables. And if I go in 1 and do length of a particular variable, you'll see that we get 30. Now, sometimes it annoys people that in this command right here, for example, when you enter that, nothing will happen. So if I want N3, for example, to be stored as the length of IQ, and I also wanted to type that as soon as I make the command, it will not only store it as N3, it'll actually type it. So all you have to do is use a semicolon and type the N3 afterwards. So, guys, next thing we'd probably be interested in would be looking at a histogram. So if I want to look at a histogram of IQ, it opens up. Guys, this is really easy to copy and paste. You can come up here to File. Let's see, actually we can go to Edit, we can go Copy. So we could copy this, paste it into a Word document. Another thing we may be interested in to determine outliers. As you would expect for IQ, we have a symmetric distribution. And we could also look at a box plot, for example, for what else we got going on here? LSS. I have no idea what this will look like, but looks something like this. Now, one more feature here. We notice that we've got a couple of categorical variables. For example, school district. So that's SCHDIST. Now these 1s, 2s, and 3s, all they are is placeholders. This is school district number 1, school district number 3. Obviously 1 and 3 aren't additive. But if you type mean school district, it will treat those as if they're quantities, so it'll add those. So what we have to do there is we have to set factor, and I'm going to set this as gender now this is going to become really important when we start running our t-test. So now we're going to set the factor, a gender, as a factor. So now it's taken the variable gender and has made it a categorical variable called gen factor. I want to do the same thing for school district. So now when I access SD factor, school district factor, it's going to treat this as categorical data. So for example, now if I go mean, gen, what else do SD factor, it's going to give me an error because it says, okay, dummy, you're trying to do a mean for a categorical variable. All right. So now that we've got the categorical variables set up as categorical variables, we can start looking at, for example, a box plot across. For example, we could look at IQs across gender, and it turns out that we would do a box plot, and we would put the quantitative first. Now, next thing we do is called tilde, and then we come in as gen factor. So what's going to happen now? As you would expect, we're looking at IQs across gender. And when I look at this, the distinguishing features that I see is, first of all, there's a lot more variation in IQs across males than females. Female has an outlier, and the IQR for males is a lot more than the IQR for females. It's clear to see the Q3 is higher for males than females, the median is higher for males than females, and Q1 is just approximately equal for both. So let's shut that down. Now, let's say we wanted to make our box plot a little more entertaining. If you notice, when I did this previous command, I got in its simplest presentation the box plot. Now, I can come in actually and give some labels. So if I want the main label to be IQs over gender, and then I could come in and maybe give the X label, and their X label is IQs, and I could do Y label equal gender. Now we're going to get a little bit more. We get again the heading, we get our horizontal label, and we get our vertical label. So you can come in and do that, make your box plot a little bit more exciting. All right, gang. What I want to do now is demonstrate unpooled and pooled t-test using, let's do read over gender. Now, it turns out this is very, very easy to do. There's a command that just does it, kind of wham, bam, thank you, ma'am, and that is called the t-test. So if I do a t-test and do, what do we say we want to do? Read over, and remember we have to use the factor of gen factor. You can see what it does. First of all, it gives you the heading of a Welch 2-sample t-test. Guys, Welch 2-sample t-test is just a fancy way of saying we did an unpooled t-test. And remember, the unpooled t-test has this wacky degrees of freedom, as we used to call it in 2500, the big O degrees of freedom. And you can see our test statistic is negative 0.31, and our p-value is 0.77. We tested, as it would in the default that we're testing not equal to, so we didn't do a directional test. And down here we get the 95% confidence interval for the difference of the sample mean, the population means. So here we get the sample estimates, so we can see that we get group means for female and group means for male. Even though the male mean was a little higher than the female mean, it wasn't enough difference to contribute to anything other than just sampling variation. Now, what if we want to do a 2-sample t-test that's pooled? Well, we do the same thing, really. But then we come in and put this command. Now, a couple things to point out here. What we're doing here is we're just putting another condition on the t-test, and this is the variances equal. And remember, if the variances are equal, we're absolutely positively certain that they are, we can run a pooled t-test. Gives us, well, I was going to tell you about the power, but that's your job, okay, to come up with that on the next assignment. I don't know why, but this part right here, the true, a lot of times we set that to true, sometimes we set it to false. That always has to be capitalized for all. So guys, if we conduct that, you can see that we did a 2-sample t-test. It doesn't give the Welch. Again, Welch indicates unpooled, and if we don't have Welch, it means we did a pool t-test. And you can see here that we have a lower p-value, obviously indicating we got more power because we have a better chance of rejecting the null. Everything else held constant. Kind of interesting, having said that, notice that the confidence intervals. Notice that the margin of error decreases quite significantly. But guys, in either case, running the unpooled t-test, running the pooled t-test, we find no significant differences in read across gender. Now, as we're going to learn, we can't do t-test, for example, across school district because we have, what, 1, 2, 3, I think 4 groups. So, guys, we'd have to run into Nova there, and we'll get into that soon enough. So, guys, what are the things I wanted you to be able to do? I wanted you, first of all, to be able to get your working directory and then be able to set the working directory so we can go to the desktop and get a file. Guys, I want you to get into a habit of saving Excel files as CSV. That sounds like a drugstore. CSV form. And again, can we move an XLS format into R? Yes, we can. But I've read on this, and my experiences with R find that the CSV is just more stable. So we've got our data in. What's the first thing is naturally we want to do once we get data saved? Do something with it, right? Find the mean, the median, histogram, whatever it may be. Guys, you can't do that. First thing you have to do is you have to attach your data before actually working with the variables in the data set. So what I've done here is found the mean. This gives me the median, the 5-number summary. I can go ahead and find the standard deviation, IQR, and so on and so forth. Okay. This part right here, remember, R is sensitive to. It's case sensitive, so keep that in mind. Skewness, I have no earthly idea what happened here because I've ran that very same command probably hundreds of times in its work, but I'll get that one figured out. Another thing I want you to be aware of, N has to be solved, and the command for that is length. Length gives you 2 different commands. If you do length over your data, it gives you the number of variables that you have. If you do length over a variable, did I say that correctly? If you get length over your data set, it gives you the number of variables. If you take length over one of your variables, then it gives you your sample size. This part right here says that if you store something and you want to see the answer to that, then you have to type in that form. Okay. The rest of the stuff here shows you how to get a histogram, how to get a box plot. This step right here, again, is a reminder that when you have categorical data, the R doesn't read it as such unless you use the factor command. So gender, M's and F's, it would try its best to add those. As we put the factor here, it's going to set it up as a categorical variable, and we can use it to do things like a simple t-test. Well, guys, that's all I've got. I'm going to upload this again to YouTube, which you obviously will know by the time you watch this. So this was on January 21st, so I guess I'll see you on Thursday.